All right, this is part 2 of the homework. Um, the number 3 says if P, then Q and R. So I'll make my initial list. Starts with if P, then both Q and R. And then the next premise says not R. And now remember, we're taking the opposite of the conclusion. The conclusion is not P, so I'm going to say not P. All right? And we're taking the opposite of the conclusion to see if there's ever a case that we can have the premises true but the conclusion false. That's what we're doing. Because if we have the premises true and the conclusion true, great. But is that the case in every single time? Since we're not sure, then we don't know if we proved it. If every single time you have to have the conclusion, then that proves that the premises prove the conclusion. All right. Well, the not rule is the easiest. Not P. Over here you see it's kind of like two negatives, just turns into a positive, right? Not P turns to be kind of like a negative, I should say, because it doesn't. The knots are not totally like negatives. All right. Again, now I have something with an if then and. I have two rules, and when we're doing these, we're kind of going outside in. All right. We have an if A then B. That's my if then rule. So here's kind of what it looks like. Once again, I'll see. Hopefully this this highlighter makes it make a little more sense. You have an if A then, and this whole thing right here is a B. The Q and R is B, right? So when I apply my rule is right here. You split them off and you say not A, then A over here is P, so we're going to say not P. And over here, we're going to split over to B. Now B is Q and R. So I'm going to write Q and R. So I'm going to put a check. I forgot to check this one. Check. And then I have an and my and says if you have A and B, that's only true when both of the cases are true. A is true and B is true. So you have to have both. So I'll apply my rule Q, R, check. Now over here I have a not P, P, that's a contradiction. Good. Over here I have an R, not R, contradiction. Again, this is valid. And if you don't remember why putting X's makes it valid, like if they're all X's out, that's valid, go ahead and check back on the notes or check your last video of the homework. I explained it a little bit more there. All right, 4. Let's see what 4 says. Oops. 4. Oh yeah, 4 is the one where is one of the two where you have no premises, just a conclusion. All right. Now this one, the homework said was invalid, right? So how do we do this though? With it's just conclusion, no premises. Well, we make our initial list just like always. We don't have to list any premises because there are no premises, but we do have to list the conclusion, and we have to negate the conclusion. Remember, we want to say, is it ever possible for this thing to be false? So I'm going to say not. Now there are two front parentheses here, but remember, you have to negate the whole thing. So I'm going to have to make 3 now, so it's going to be incredibly ugly. Not the case that if you have P, then you have Q, then you have Q. Oops, that should be Q. Right, and one more. Then you have Q. All right. Now, you may wonder which way are we working here. We're going outside in, right? This whole thing right here, is A. And then I have an if then, and then I have a B. Q is B, right? So we're going to have to split these things up. The first one, the A, oh no, I'm sorry, this is a not. So we're not splitting it up. It's a not if then. And the not if then is this rule right here, and you go straight down, right? So the A here is if B then Q, then Q. The B here is Q. So I'm gonna have to say not B. So here's what we're gonna do. A is if P then Q, then Q. B is, or I should say not B, is not Q. Check. That one's done. Now I have an if-then statement. And remember, once again, we're working kind of outside in. This whole thing right here, this front thing right here is going to be an A. If-then B. And if you were wondering, like, well, how do I keep straight in my head which one I should do first? Well, if you applied the if-then rule to this guy right here and you split it out, right, not P then Q, then you'd have not P then Q, and you'd be sitting over here like, well, now what do I do with this guy, right? So that kind of makes a little more sense of why we apply the rules the same way. If you apply it in the inside first, then the outside guys are just stranded, not doing anything. So you're gonna have to take care of those guys, the outside guys first. So first we're gonna split it out because this is an if-then rule. Not A then B. My A is if P then Q. So I'm gonna split it out over here. Oops, that was the wrong thing to do. Get my pencil back. Split it out way over here, so I have some room. And I'm gonna say not, and I'm gonna have to do the parentheses if P then Q. I don't want to say if not P then Q. I want to say not the case that if P then Q. Then on this side will be Q. Check. And if you want to know why you have to have the parentheses, let's see, it would be something like having the parentheses there. I want to say something like it's not the case that if you have cookies, then you have to have milk, right? Whereas without the parentheses, if I took off the parentheses and it says if not P then Q, that would be something like instead like if you do not have cookies, then you have milk, which obviously is false. But when I put the parentheses back on, it's not the case that if you have cookies, then you have milk. That makes a little more sense, right? So that's why those parentheses are important. All right, so then the last thing I have is a not if then. This rule right here, right? And it goes like this: P, not Q, check. I'm going to look back up here. Not Q does not contradict anything over here. Oh, I have an open branch. Q contradicts not Q over here, so this one's closed. But that doesn't really matter, right? As long as you have one open branch, that means it's possible that the conclusion be false while the premises be true. And I don't have any premises here, but it's possible for the conclusion to be false. So I haven't proven the conclusion. It's not the case that the conclusion is proved. So then this is invalid. Let me take a different color pencil just so we can not get confused. Come on. I'll do it in purple. Alright, so this is invalid. And now I have to do a counter model. Now, a counter model, all that means is you start with one branch, or you take one branch actually, you don't do any other branches. You're going to do a counter model for one branch, and this is going to be my branch. There could be other branches where there are not contradictions, other branches that are open branches. I don't really care. I'm going to take one branch only. This is a counter model for the branch, and this is what a counter model means. It sort of tells you what things have to be true and false in order for there to be the premises to be true and the conclusion to be false. What propositions, what propositions here, like Q or P, what do they have to look like in order for the premises to be true and the conclusion to be false? And that shows you that that's the one place where the premises don't prove the conclusion. So here, V is going to mean truth value, something like truth value, right? The truth value, and first I'll write P. The truth value of P, that's what the parenthesis says. Truth value of P equals, and it's going to be 1 for true and 2 for false. For the truth value of P equals 1, because in this branch I have a P and I don't have any not P's. If you ever have a P and a not P, right? If you ever have the case where P equals 1, but you also have a P equals 0, then you know that was actually a closed branch you messed up, like that you just missed that. It should never be the case that you have both, because that's a contradiction. So, and then now we have the truth value of Q. Truth value of Q equals 0, that means false, and it equals 0 because I have not Q here, right? You could do the truth value of not Q and that would equal 1, but that's kind of not the way you do it. So yeah, truth value Q equals 0. We got one more. I'll try to do this one. I'll try to do it a little quicker, but let's see. All right, the last one. Again, this one's a conclusion only, so I'm going to do a not, and again, I have to do parentheses around the whole thing. A not, if P then Q, and if not P then Q. Oh, it's getting ugly. then not Q. Oh my gosh. Oh man. Well, let's see here. Hold on a second. Let me cut this. Oh, that's not what I meant to do either. Alright, here we go. I'm gonna cut this. And then I'm gonna pull it over here. Oh! I didn't mean to drag that Q. Let's erase that guy. I don't want that. Alright. And this is supposed to be, I don't know what that's supposed to be. That's supposed to be a not Q. Let me rewrite that one. Not Q. Alright. My stylus doesn't work very well, you can see, so doing the best I can. Alright, so the first rule I'm going to be applying is the outside rule. Oh, this is going to have a parenthesis out there. And that's the if-then rule over here. It's a not if-then. Right? So my whole thing over here, oops, this whole thing right here is A. And this whole thing over here, let's do it in a different color. This whole thing over here is B. Alright. So, the not rule says you write A and then not B. My A is if P then Q, and not P then Q. And my not B would be not Q. Because remember, B is not Q, right? So don't let that confuse you, right? It says not B, but the whole B is, all of B is not Q. Not so that's done. So check. That should be check. Not rule is the easy rule, so let's do that one. Not Q just means Q. Check. And rule is actually pretty easy too. You just write them straight down, right? This and is only true when both these sides are true. So on this one, this is my B over here. This is my A over here, right? So I'll write my A first. If P then Q, then I'll write my B. If not P then Q, this one's done, check. Now I'll write my if then rule. That's what I got right here. If P then Q. We'll split them out. And now if P then Q is, I'm doing this one right here, okay? So I'm not that one, I'm doing this one right here. This one says A turns into not A. All right, so this is going to be confusing because there's not P here, right? These look really close to each other. So I'm doing this one, so A is going to turn into not A, so P is going to turn into not P. And Q is going to come over here. That one's done. Check. And now I'm looking at this one, and again, same rule. A turns into not A, but my A is not P. So not P is going to turn into not P. Not P, Q, not P, Q, check. And then I have a couple nots down here, right? P, check, check. All right. Now I don't have any propositional parameters up here. They start right here. The Q is the first one. So I'll just move this up so we can see a little bit better. And I start down here. P contradicts not P. I'll cross that one off. Q does not contradict anything up here. Not P does not contradict anything up here. And then there's just a Q right here. This is an open branch. I don't have to go any further if I don't want to. Just one open branch shows that there's a possible way where this conclusion is false. I assumed that the conclusion was false way up here. I said, let's pretend this whole conclusion is false. And I said, is that ever possible? And here I found, yes, it is possible. So I don't have to go any further. So I'm not going to go any further because I said I was going to try to do this a little more quickly. I'm going to circle this whole branch so you know which one I'm working with. And I'm going to say this is invalid. Invalid. And my counter model will look like this. The truth value of P will equal 0. And it equals 0 because not P is in here, right? So P is false. So the truth value of P is 0 because 0 is false. And the truth value of Q is going to be 1 because I have a Q here. That is it. Please email me if you guys have any questions. Otherwise, we'll talk about it more next class.